Hi, this lesson we are going to look at the sine rule, which states that in any triangle ABC, A over sine of angle A, so A over sine of angle A equals to B over sine B, which is also equal to C over sine C. So the A over sine A, so A over sine A is equal to B divided by sine B, which is also equal to C divided by sine C. We can also rewrite this equation in this format. Sine A over A equals sine B over B, which is equal to sine C over C. When you are solving for a side, you want to find the length of side. This is how we write it. If we are trying to work out the size of an angle, it's better that we write it in this format. Let's look at some examples. In this example, they say, in triangle ABC, angle A is 70, B is 50 degrees, and B is 12 centimeters. You need to know how to fill this in a diagram. So if that A is 70 degrees, so I've fit 70 degrees and an angle over there. And then angle B is 70 degrees, angle B is 50 degrees. And then they said B is 12 centimeters. Remember that B is a small letter B. It's a side which is opposite capital letter angle B. And the side is over there. So that is a small letter B, which is 12 centimeters. Now they want us first to calculate the length of A, and A is a side which is opposite and a capital letter angle A. That is a side which is over there. So now I want to find this thing. So if I want to find this length here, it's easier if you just cross multiply like so that you can see it, and that one cross like that. And because we've mentioned before that we want to work out the length of the side, we rewrite this like that instead of writing like that one. So we write like this one. So we'll say to work out A, so I'll say A over sine of an angle 70 degrees is equal to the side, which is B on that side there, which is 12 centimeters, divided by sine of an angle which is opposite B there, which is 50 degrees. Now I'm solving for A, so A will be equal to, so this will cross multiply, so we'll have a sine of 70 degrees multiplying a 12, which is divided by a sine of 50 degrees, and therefore A is equal to, I take the calculator, so the calculator on, so then I've got a sine of 70 degrees, which is multiplied by a fraction, which is a 12 divided by the sine of 50 degrees, and the answer from the calculator is 14,7. So the answer is 14,7, and the units that we're using are centimeters there. Then the next one is to find C. Which side is C? C is opposite the angle C over there. So which means I need to know that angle. Obviously from grade 8 mathematics, that angle is 180 minus the sum of this. So that angle there is 60 degrees. Therefore, to find the C, which is this side over here, I will say therefore C divided by sine of an angle opposite it at 60 degrees is equal to another side, which is at 12 centimeters, divided by sine of an angle opposite that is sine of 50 degrees. And therefore C is equal to a sine of 60 degrees, which is multiplying at 12 centimeters, which is divided by a sine of 50 degrees. So C is equal to, take the calculator, so I've got sine of 60, so sine of 60 multiplied by a fraction, which is 12 divided by sine of 50, it goes there, and the answer is 13,56, so 13,6, so you can say it's 13,6 centimeters. Done. Let's look at the second example. The second example says, in triangle PQR, calculate the size of the acute angle Q. So you want to find the size of an acute angle Q. Again, using sine rule, it's better that you've got things that can cross multiply like that. So to find Q, again, so now I'm looking for an angle, so I'm not going to use that one. Now we're using this one, because to find an angle, I'll write like that one there, as I explained before. So therefore, I'm looking for angle Q, so I'll start saying sine of angle Q divided by the side which is opposite it. so 12 meters, then multiplied by, now I must find sine of another angle, which is that one there, so it's 80, is equal to sine of 80 degrees, then which is divided by the length of the side here, which is 15 meters over here. Therefore, I'm solving for angle Q, so I'll say sine of angle Q is equal to the 12 meters, which is multiplying the sine of 80 degrees, which is divided by 15 meters. Obviously, the meters will cancel the meters, so therefore sine of angle Q is equal to, so if I take in a calculator and put this, so I'll have a 12, which is multiplying the fraction of sine of 80 close there divided by 15, and I get an answer of 0.78. Let me write the whole of this number. So it says 0.7878462024. So that's the number that I get for over there. Now I'm solving for Q. How do I find Q? So Q is, I must get an acute angle, so I must go shift there, so I'll have arc sine there, so that is how I'll get in the calculator 8784622024. So angle Q is equal to, so if I go to my calculator, go shift, then 0.7878462024, close there, I get an answer of 51.98. If I round off this number, I get 52 degrees. So angle Q is 52 degrees, and it is an acute angle. Now let's look at another one. In this triangle ABC, you've got to calculate the magnitude. The word magnitude is same as the word size. So we're looking for the size of the obtuse angle B. You can see this angle B over here is an obtuse angle. We need to work out that. Same thing, we use the sine rule. So sine rule, looking for this angle, so cross multiply there, it goes there, and then so we've got another one crossing there, so we use the sine rule. So therefore, let's try. So to find this, again, trying to find an angle, we write it this format here. So I'm finding angle B, so I would say sine of angle B, because I don't know, divided by the side which is opposite, is 9.4, is equal to sine of another angle, sine of 30 degrees, which is divided by the side which is opposite 30 degrees, which is a 5. Now I'm solving for the angle, so this cross multiply, so sine of angle B is equal to 9.4, which is multiplying the fraction of sine of 30 degrees, which is divided by 5. Therefore, sine of angle B is equal to, so take my calculator, so I have 9.4, which is multiplying the fraction of sine of 30 degrees, and then which is divided by 5, and I get an answer of 0.94. That's an answer, but I'm looking for the size of angle B. Now note that angle B must be an obtuse angle. If you look at the calculator, if I go shift, doing a shift on a calculator, it will give me an answer of, let's say, shift sine of this is 0.94. The answer there is an acute angle, but not an obtuse angle. How am I going to get that obtuse angle? I will subtract this from 180 degrees. Therefore, to find the angle B, I will say 180 degrees minus the shift of 0.94. In fact, it's arc sine of that. So the angle B will be equal to, so I have to subtract that to 180. So if I can also do it like normally and say 180 degrees minus a shift of sine, and then I put 0.94 close, and then the answer is an obtuse angle that they're looking for, 0.09,94. If I round off, this number is about 110 degrees, which is obtuse. Now, can you on your own now try these few examples from your Siavula textbook, chapter 6, you do 6.5, and it's under area, sine and cosine rule, but we're doing the sine sine rule here. So this one we'll do next time because area we've done before. So exercise 6.11, numbers 1 to 6.